Okay. Start recording all participants and need to arrange. Yes. So sometimes C is 3 plus 5x. It's written in this way, or sometimes it is written x squared minus 3x plus 1, and so on. Okay, good. If you have an understanding about polynomials, so we have rational functions. Rational functions what? A function that can be expressed as a ratio of two polynomials. It's called rational function. So if pair of x and q are polynomials, then domain of the rational function consists of all x values x such that qx is not equals to 0. So what is domain means, later on I will tell you what a domain is. Domain is the x, guys, which makes your function defined. Have you heard domain before? Domain, have you heard?
Yes, sir.
Please
I'm
say it
here.
again.
Yeah, the domain means the x, guys, which makes your function defined. So here, for example, this is a rational function. Numerator, you have polynomial. In the denominator, you have polynomial. Okay? Now, how do you find the domain? My friend, the idea is this. You take the denominator, you make it equals to 0. Okay? You find 1 and minus 1. So this means that the domain of this function is all real numbers except minus 1 and 1. Okay?
Okay.
So it works like that. Okay. Other functions also here, but it's okay. These are enough. So if someone asks you what is the domain of a polynomial, it's all real numbers, because the all x guys from real numbers make this defined. Okay. So it's like that. So I'm closing this. Let me find other notes. So we have seen this. Okay, what we were doing. Let me close this limit one. Now, okay. Now let us go back. Yes. Okay. Now we are back to the PowerPoint. Now, can you see that? This is the reason that last time I told you that. Now, the limit as x approaches to 2 of the polynomial function is simply the value of p at x is equals to 2. So you just substitute. Okay? Limit of p of x when x goes to 3 is equals to p of 2, which is 19. Direct substitution property is valid for all polynomial and rational functions with non-zero denominators. Okay, so this is in general how the rules work. If p is a polynomial function and c is a real number, then limit of p of x when x goes to c is equals to p of c. If r is a rational function given by rx is equals to px over qx, and c is a real number such that q of c is not equals to 0, then limit rx x goes to c is equals to r of c, which is p of c over q of c. I think examples will be better. This is a rational function. You have numerator, it is a polynomial. Denominator, it is a polynomial. So what does the rule says? You just use the substitution rule. Who wants to say what is the answer of this limit?
2.
Sorry?
2.
Yeah.
I think it is.
Yes, exactly. What you say
Yeah,
is
for
correct, because you substitute and then you just find the answer. So, but you know, in here denominator is not 0. We are very good. This is defined at the end. There is a number in the numerator, number in the denominator. So we are recording, right? Okay, good. Let us continue. Now, limit of a function involving a radical. So radical means we have radical means that roots functions are coming up. Let n be a positive integer. The limit below is valid for all c when n is odd and is valid for c bigger than 0 when n is even. In here, again here you replace x with c. My friends, I will come to limit of this kind of functions, but I want to remind you or inform you composition of functions. Have you heard about composition of two functions?
Yes.
Okay, so yeah, maybe you took discrete mathematics, I don't know, or maybe before you took this course, kind of this course. You have two functions, f and g. Then the composition function, this f of g, you say this O is not 0, okay? This tells you that you are doing the composition with f and g. Now this is equals to f of g of x. So first g applies to x. Whatever you find, you apply f to this. Whatever you find. This is composite of f with g. Domain of f of g is the set of all x in the domain of g, this one, such that gx in the domain of f. This is technical details. The composite of f with g is generally not the same as the composite of g. Now, why I want to remind you this, in your book, there is a theorem. I wanted to tell you about this. If f and g are functions such that limit of g of x when x goes to c is equals to L, and limit of f of x when x goes to this capital L, that you find from this the limit equals to f of L, then limit of f of g of x when x goes to c is equals to f of limit of g of x when x goes to c, and it is equals to f of L because limit of g of x when x goes to c, we say that is equals to L. Now I will solve you one question. Actually, when we are answering this, okay, so this is the question. We are answering this question. Actually, we are using this theorem. Quickly, you can give the answer of this, and using this theorem, we can understand what is behind of this quick operation. What is going on behind doing this? So in here, what you can do, you have a root stuff, and you have some polynomial inside. What you can do is just do substitution. If you do substitution, what is the answer here?
2.
Exactly. Now, this theorem tells why actually this is happening like that. Now, if we go back to here, this theorem, we have actually a composition of two functions here. One of the function f of x is root x, another one is this one. So f of g of x, this composition, this one actually, this is your f of g of x now, is equals to f of x squared plus 4, and you get exactly this expression. So did you understand how this composition happened?
Yeah.
F and g? Yeah. So when we say again, like as your friend say, he immediately say that is equals to 2. So he just placed this 0 to here. So in actually what is going on? So this theorem is holding. Now here limit of g of x is L. So our g is this guy. Look at this limit. X goes to c. Now x goes to 0. It's equals to what? 4. This 4 is your L. Okay. Now you are looking the limit of f of x. X goes to L. L is what? 4. Okay. And it's equals to 2. Now what is happening from the theorem? From the theorem, we say that this limit is equals to what? F of L, which is 2. So from theorem, we can say this limit is work like that, but you know, it's quite long story. What you can do if you have roots, and you can just, and then you find your answer. Similarly, what is the answer of this? In a short way?
Again, 2.
Exactly, you are very good. But again, you can think that like your f of x is radical, so root function. Again, your g of x is this guy, and so on. You can also conclude this, check this using this theorem, but you need to work again hard. This is explained here. But again, as your friends say, shortly, this is equals to 2. Okay, because 3 times 3 square is 9, 9 times 2, 18, 18 minus 10, 8, and this gives you
square
2.
2.
Yeah, yeah. Okay, right. You have seen that limits of many algebraic functions can be evaluated by direct substitution. The basic transcendental functions, trigonometric, exponential, and logarithmic, also possesses this desirable quality as shown below theorem. My friends, this theorem 2.6 tells us how to find the limits of trigonometric functions like exponential and logarithmic. Can you see what's going on with trigonometric? You just substitute. But this C, guys, is in the domain of the given functions, okay? So this transcendental function means it can be trigonometric, okay? So limit of sine x when x goes to c is what? Sine c. Limit of cos x when x goes to c is cos c. Limit of tan x when x goes to c, tan c. Limit of cotangent when x goes to c is cotangent c. Limit of secant x when x goes to c, secant c, you know. And limit of cosecant x when x goes to c is what? Cosecant c. This is exponential function. You have a is bigger than 0. It's like green number is here, okay? Limit of a to the power x, x goes to c is equals to what? A to the power c. Limit of ln x when x goes to c is what? Ln c. Okay? So we have these equations. Limit of tan x, x goes to 0 is tan 0. Everyone knows why tan 0 is 0? Do you remember? Eh?
Why tan is 0?
Actually, this is coming off from trigonometric knowledge. Let me. Do you know what is tan x is equals to? This is sine x over cos x. You remember?
Yeah, sine.
So sine 0 is 0, cos 0 is 1. So 0 over 1 is what? Understand?
Yeah.
Yes.
Yeah, exactly. So for that reason, we say that this is 0. My friend, we have a notation here, terminology. Now, beforehand, from this PDF, I want to show you. My friend, can you see that? You have this power. So sine square x. So this is the square of sine x. Okay. But instead of this, we usually write like that. So we write this the power 2 just before x. Can you see that? When you see this, you will understand that we are taking the square of, for example, sine x. So, for example, if we have this, you will understand that you are taking the cube of cos x. Do you understand this terminology?
Yeah, of course.
Yes.
This also applies for tan, cotangent, secant, you know, for all trigonometric functions. These powers works like that. So here, for that reason, this is equals to like that. And we know that from the properties of limits, this is equals to what? So firstly, what is the limit of sine x when x goes to 0? Sine 0, we learned that it's 0, right? And 0 square is 0. You okay with this?
Yes.
Here, we have two functions, f and g. What we learned today, you can separately look at the limit and multiple. What is this? This equals to minus 1. What is this? This is exponential function. Now your a is e here. Okay? This is e to the power minus 1. The answer is what? Minus times e to the power minus 1. Here, my friends, this is a
Can I ask something?
Yes, yes.
About example A.
Mhm.
If x was 90, what will happen? Because 1090 is undefined.
Yes. Later on we will say we will say infinite. Okay? Infinite limit. Sorry, infinite limits. We will learn infinite limits also. We will continue from this infinite. When I come to this infinite limits, actually, you will have a better idea graphically and other things. Okay?
Okay.
So we will call this infinity. Yeah, because sine 90 over cos 90, and sine 91, 1 over 0, it will be infinity. Okay? But actually, when we are saying that, yeah, we need to check from right and left. Because sometimes from right and left, you can have different kind of infinities. And so on. This is technical details. But you have some idea. Okay? I don't know who asked this question. I think, who asked this question? Ruth? Ruth, who asked?
Me.
Ah, Buse.
Me.
Okay, so Buse,
Yes.
you have some idea. Yeah. Okay, good. Now, what we were doing, this ln, guys, we will learn later. There are properties. Maybe in this PDF I already explained. Yeah. So this is a property. So ln xr. So this is logarithmic function. When this base is equals to e, this is ln function. And if you have power like r, you can take the front is equals to r times ln x. But later on we will see this property. But these books just want to give this example at that time. Okay. So this is equals to 3. So this is 3 times ln x and 3 times ln e and 3 times 1. The answer is 3. Okay, my friends. Do you understand this? Yeah, just someone is knocking my door. I need to talk with this guy. Okay, after the class, I have lesson now. Okay, time 20. Yes. Okay, now let's going on. A strategy for finding limits. Theorem. Functions that agree all but one point. Let C be a real number and let f of x is equals to f g of x for all x is not equals to c in an open interval containing c. If the limit of g of x as x approaches to c exists, then the limit of f of x also exists. And okay, maybe it's better to make it, slight mode. Yeah, now more clear. Limit of f of x when x goes to c is equals to limit of g of x when x goes to c. What does this mean? It's super easy. And I will tell you with example what is going on. My friend, I want to ask you something. What do you think? What will happen? What is the answer?
0.
Are you sure?
Undefined.
No.
We are coming two sides.
Sorry, it's 3.
No, wait. So
0.
if you replace x with 1, numerator gives you what?
Okay, it is undefined because the downside is 0. Undefined.
It is indeterminate form. Now,
means not 3.
this means that you need to do something in an informal way. So this means that you need to do something. The answer is not so you cannot accept 0 over 0 as an answer. This means that you can go on and find the answer. That's indeterminate form. So what you do, you look at the function more carefully and see if you can factorize. So from binomial theorem, you can write this as like that.
Okay.
So this is like like this is giving you a warning. When you see 0, 0, oh, you need to do something. This says that you need to do something. You need to do something. And say, okay, I will do something. And then you think what I can do. You look at your function more carefully, and you see that in the numerator you have an expression that you can factorize, and you can see that when you do this, this x minus 1 simplify with this guy. So what happens when you do this? Sorry, you have g of x. Okay, now after simplification you have g of x. So for x is equals to not 1, of course, because if x is 1, this is not defined, you know. So what is this theorem says that limit of this is equals to limit of the simplified form. This is what is told here. Now we come to the simplified form. Now this is a polynomial. What is the answer?
3.
1 plus 1 plus 1. Exactly.
Yeah, 3.
Yeah. So this is one thing. When you have 0 over 0, this is one thing you need to do. Okay?
Okay.
For limit analytically easy, dividing out technique. This technique involves dividing uncommon factor. This is what we are doing.
We need
Now
to
look
do
at
drive, sir.
no dividing out technique. Dividing.
No, before this question. Yeah, we need to do drive too.
Divide.
Drive. Tref. I need to say tref.
Sorry, I didn't get what you mean with. Maybe I didn't understand your terminology. So in here, sorry, can you tell me in here or here what you mean?
Can I say Turkish?
It's not good. Turkey is not good idea. So just tell me in which step, in here, or in here. Which one? First, second, third?
Third one.
This one.
First one I say, how can I say?
From here, from binomial theorem, we write this in this form. We factorize. Okay? First form.
Okay.
Then
He's talking about derivative.
this is not derivative. Maybe you're saying, I don't know. Derivative is different thing. If you are saying derivative, I don't know your terminology. Maybe it's okay, but what I am doing is clear. Am I right? Okay.
If we use derivative, we get same thing. No, right?
My friend,
Because
derivative.
we get nothing if we use 1.
Okay, firstly, we haven't seen derivative yet, and we are not doing derivation here because we are doing limit. Okay?
Okay.
Derivative is totally different thing. Derivative is, if I ask you what is the derivative of this function, then you can use quotient rule and answer. Or, I don't know, maybe some other methods. But this is limit question. You are taking limit of this function. So what I do is related. Okay? Maybe you want to solve in another way, but let's step by step, because now in the class lots of students, and I want to teach in a way that everyone can understand. Okay, my friend, but this is not the derivative question. This is what I can tell you. There are methods, L'Hopital rules, other things. You use the derivative when you are using L'Hopital. Maybe you are trying to say L'Hopital rule, but later on we will see L'Hopital also. Okay, my friend.
Okay.
Thank you for your understanding, and thank you for offering any other techniques. But I will answer you when we come to this subject. Okay. Now, if everyone is fine, we find the answer 3. Is there any problem with this? The method and what we did?
No, not a problem.
Okay. Now, this is dividing out technique. This technique involves dividing out common factors. My friend, we were doing this question. Now, what we will do? Again, the same. What happens? If you send x to minus 3, what happens? What will you find?
Sir, is the answer is -5?
X plus 2. No.
Okay,
no,
maybe you have some.
X
It is 0 over 0.
plus 3. Okay. 3.
It is
Yeah.
0.
0 over 0. You should check your calculation again because
Minus 5.
No, I don't think so.
It is 0 over 0.
0 over 0. Look, minus 3 to the power 2, 9. 9 plus minus 3, 6. 6 minus 6, 0. Here, 0. It's 0 over 0, okay? See? Understand, my friend?
Yeah.
Okay. Now, this is again 0 over 0. What do you think?
Okay.
Yeah, you can factorize, right? Which one? Numerator or denominator? Of course, numerator, right? Can you see that?
Yes.
Now, after factorizing this and simplifying, you get that this limit is equal to this limit. Are you okay with this?
Yes.
Now, what is the answer?
Minus 5, I say.
Yes, actually, your friends say the correct answer. I don't know if you did quickly like that, but at the end, we hit your friend's answer. Yeah.
I use my technique in my mind.
Yeah.
Yeah, and me.
You are very good. Okay.
Okay.
Now, but anyway, now is this okay? This my explanation okay? My friend, just what this book? The book just take this f of x at somewhere and he did the cancellation other things. But so this is in here. In this one is simplifies, you know, and then this limit becomes this because you simplified your function like that. I think it's clear, and you find minus 5. But you know, sometimes maybe you need to factorize the denominator. Okay. In these two examples, we were usually playing with the numerator, but maybe sometimes in the denominator you have something that you can factorize. Maybe sometimes you will have some expressions you will factorize numerator and denominator at the same time. This can be also possible. So in tutorial questions, you have different situations, but this is the idea. In here again, it says you what I said informally. Direct substitution produces the meaningless fractional form 0 over 0. An expression such as 0 over 0 is called, again I am telling you, indeterminate form, because you cannot from the form alone determine the limit. When you try to evaluate the limit and encounter this form, remember that you must rewrite the fraction so that the new denominator does not have 0 as its limit. One way to do this, to divide out common factors. This is what we did so far. So we divide out the common factors here and also in the other example. This is about divide out. My friend, now we will see rationalizing technique. Rationalizing. Now, before rationalizing, I want to show you something. Okay. Do you know this conjugate story? Okay, before that, do you know this identity? A minus B times A plus B is what?
A power 2.
A square minus B square. Do you remember this?
Yeah.
Yes.
Yes.
Yeah. So when we are working with radical gas, with root guys, yeah, this is very helpful. So the conjugate of this guy, for example, is this one. And the conjugate of this one is the guy on the left one. Because when we do this operation using this identity, we get rid of from where? The root. Because this will be what? A square will be what? X. Right? Now we don't have root anymore. And this from here we get here, we already have number. So this is, for example, is equals to x minus 16. So this is how the conjugates. And now I want to tell you something. I will come to take this. Now, for example, you have 3 over 5. My friend, 3 over 5, you can write like that, right? 3 over 5 times, let's say 9 over 9. Am I right? Can I write like that?
No.
Why?
Yes.
Because this is 1. This is 1.
No. Okay.
Right?
Yeah. Yes. 9/9 equal 1. Yeah.
Yeah, the idea is, so you multiple 3 with something and divide with the same thing. So this doesn't affect. Okay, but this is not something, this is not 0. So 9 over 9, for example, 5 over 5 or 8 or whatever. Now, we will use these ideas and this idea together now in the coming rationalizing technique. Let me do a slideshow. Okay. Now, another way to find the limit analytically is the rationalizing technique, which involves rationalizing either the numerator or denominator of a fractional expression. We know that rationalizing the denominator means multiplying the numerator and denominator by the conjugate of the numerator or denominator. It depends on where you are doing this rationalizing. So, for instance, so this is because this is not rational function, because you know this is not a polynomial. But how we will do? Now we will rationalize the numerator of this, multiplying the numerator and denominator by the conjugate of this guy. What is the conjugate of this? Root x minus 4. So if you multiply numerator and denominator, okay, then this expression will not change, because root x minus 4 over root x minus 4 is 1. You know, it doesn't change, but then you can get rid of from root stuff, okay? Okay, maybe I should explain here. So root, what does it say? Root what? Root x plus 4. So this is what is explained here. Root x plus 4 over is x, right? X. So this was explained. It says that this you multiple and so this and same. Understand? This is what is said in this. Because now if you can this guy times this guy, I told you what? X minus 16. So the answer of this now x minus 16 over x times root x minus 4. Okay, this is what I explained here. Now, how we are using these ideas when we are solving the equations? So this is the thing, because we want to solve the equations. Now, can you see that? Find the limit. Can you see?
Yeah.
Now, this is not a rational function. Now, if you set x to 0, what you will find?
Zero over zero.
0.
Yeah.
0.
Not
Yeah.
0 over 0. 0 over 0,
Yeah.
not 0.
Yeah.
Now, detail written here. Now, my friend, now the idea, I just told you that 9 over 9 story is the same thing. What we are doing, we are taking this guy. Now, we need to get rid of from where? The root. So, you multiply, you multiply the numerator. So, okay, I am taking this to here, okay? I'm multiplying this with, it is conjugate. What is this conjugate? The plus version. Now, you should multiply this expression with the conjugate of this, both in numerator and denominator. If you don't do denominator, then this will not equals to this one. This is because equals to 1. Do you understand why this is equal? Because this is 1.
This is one. It's like the 9/9 story I told you. It's the same thing,
Yeah.
same idea. Now, second step, you are using this idea now. Okay. So this is your A, this is your B. A square is now what? X plus 1 minus B square is what? 1 to the power 2, 1. So in here, this guy multiple with this guy gives you this one. In the denominator, you have what? X times this guy. Now, X plus 1 minus 1. This 1 simplify with this 1. Now, X over X times this guy. Is this okay?
Yeah.
Okay. So this X simplified then, and you get this. Are you okay up to now?
Yeah.
Okay.
Yeah. Okay, teacher.
Very good. Now you have this at the end. X is not equals to 0. My friend, now that means that this limit is equals to this limit. After doing loss. Now what is the answer?
1/2.
1 over, exactly, your friend is very good. Yes, we have the answer. Again, I am telling you, there can be questions like, for example, this radical guy not in the numerator, but maybe in the denominator. So you will do the same things, but now starting from the denominator, okay? There can be different stories. So check the tutorial this week. Hopefully he will manage. We have a squeeze theorem. Have you heard squeeze theorem? It's super easy. The squeeze theorem. Now, h of x is smaller or equals to f of x is smaller or equals to g of x for all x in an open interval containing c, except possibly at c itself. And if limit of h of x when x goes to c is equals to L, and L is equals to limit of g of x when x goes to c, then limit of f of x when x goes to c exists and is equals to L. This squeeze theorem is also called the sandwich theorem or the pinching theorem. Firstly, did you understand what is going on here?
Yeah.
Okay, now with one example it will be more clear. Now, question. If 4x minus 9 is smaller or equals to f of x, and f of x is smaller or equals to x squared minus 4x plus 7, for x is bigger or equals to 0, then find limit of f of x when x goes to 4 using squeeze theorem. Now, can you see that we don't know what the f of x is? And the guy is asking us limit of f of x. We don't know f of x. But what we know that 4x minus 9 is smaller or equals to f of x is smaller or equals to x squared minus 4x plus 7. Now, remember the theorem. Now you look at this limit of this guy. In here, this is h of x. Am I right? This is your h of x. This is your, this is your what? G of x. Now, limit of this is h of x is what? 7. Now I check the limit of this. It's again 7. Are you okay with this?
Same. Yes.
Yeah, exactly.
Yeah.
Same, but they have to be same. Then theorem says that even you don't know what f of x is the limit of f of x when x goes to 4 is also 7. Understand?
Yeah.
So this is how squeeze theorem works, how it helps you. Even sometimes you don't know the function, you can answer the limit question. Okay, good. We have some special limits. Again, Now look, limit x goes to 0, sine x over x is 1. Limit x goes to 0, 1 minus cos x over x is equals to 0. Limit x goes to 0, 1 plus x to the power 1 over x is equals to e. My friend, if you know like L'Hopital rule, you may immediately see why this is like that. But for now we don't know, so we will know this as rule. In the questions using these ideas, let me explain you. So look at this. Find the limit of tan x over x when x goes to 0. Now, direct substitution gives you what? 0 over 0. What we will do? We will use the this identity. So sine x over cos x. So instead of sin x, I write sine x over x. Now I just separated. So I take the cos x to the right hand side here. I can do. Now what happened? Sine x over x, 1 over cos x. Now with this, I know that sine x over x is 1 from the theorem I just told you today. And 1 over cos x is what? Cos 0 is 1. 1 over 1 is 1. So what happened? This is equals to 1 times 1, which is the answer is 1. Okay, you understand?
Yeah.
Yeah.
You okay? This is geometric approach. I'll skip this and I want to solve you one more question. Okay, support file, right? This is an interesting question. Okay, look, can you see that limit of 4x over x when x goes to 0? Now, direct substitution gives you what? 0 over 0. My friend, what you are doing, at the end, I want to use this rule. Can you see that? Limit of sine x over x when x goes to 0 is equals to 1. My friend, this is also okay. Like instead of x, you can write y here, for example. Limit y goes to 0, sine y over y. It's also 1, okay? Now, I want to turn this to a kind of this form. What I do, I multiply the denominator and the numerator with 4. And then take 4 out. Do you understand what is happening here?
Yes, I understand.
Okay. Everyone understand?
No, I'm sorry, teacher. Can you just repeat this point?
Okay, 1 minute. I need to do command and pencil for you. Look, this is happening. Limit x goes to 0. Now sine x. Okay, sine not x, sorry, 4x. Sine 4x. Okay, x. Now what's happening here? We are doing this. Limit, okay, x goes to 0. Look, now this is the 3. Now sine 4x here, okay. Now but here it was x, right? So what is the trick? You multiply here with 4, but 4 also here, isn't it? So 4 over 4 doesn't change anything. Am I right? 4 over 4 is 1, right?
Yeah.
But do you remember we have a limit rule? You can take this r out. So it's equals to 4 times. Sine 4x. So this is the 3. Okay? Do you understand? My friend, do you understand the trick?
No.
Yes.
No? Okay, which part do you understand? This part, did you understand this part? It's okay, right?
No,
Here-
no. I don't understand this part.
This one, huh? So, okay, this equality you didn't understand? Look,
No,
okay, 3 over 5 is equals to 3 over 5 times 4 over 4. Am I right? Do you understand this?
yeah,
So this is the same thing. So this is not 3 but sine 4x. This is not 5 but x. This is equals to 4 over 4 times sine 4xx. You understand?
yeah, I get it.
The same thing, but you don't have 3, you have this. But okay,
Yeah,
I am very
I
glad.
get it.
Yeah, you are very good. Now what I am doing, I am just taking this 4 out now. 4, because do you remember we have a rule we were doing, so we are using this rule, okay? Like this one I explained in the beginning of the class, this rule. B time f of x, you can take b to the front. Do you understand?
Yeah.
This b is now what? 4. Okay?
Okay.
Can I
Yeah.
ask something?
Yes.
We are taking coefficient of sin and dividing coefficient of x. Is it right?
Yes, exactly. Yes, exactly. 4x. So to make this 4x, you should multiply x with 4. But then you should multiply also this whole thing with 4, because 4 over 4 is the 4 over 4 then will not change. So this is what I did here. You understand?
Yes.
So this 4 over 4 multiplied with 6. Okay? Okay, good. Now the story begins. So you take the 4 out. Now, my friend, we will use this rule. So what we do, we change the variable. So for 4x, we say let y is equals to 4x, okay? So then sine y over y it comes. But now, look, if y is 4x and if x goes to 0, 4 times 0 also goes to 0. So that means y also goes to 0. So you can change this in this way like that. Do you understand?
Yeah.
Because now 4x we said y.
Change
So
x. Change.
we change.
Yeah, x to y. Yeah.
Yeah, variable changing. We said 4x is y.
Yeah.
Okay.
Okay.
So
Yeah.
y and y. But this you have to change this also to y. Why you can say that y also goes to 0? Because if x goes to 0, 4 times 0 also goes to 0. So that means y also goes to 0. So you can change this like in this way. Now we know that this is equals to 1. Theorem you can also think like that with different variable. Now the answer is 4. Okay?
Okay.
yeah.
Okay. With this I finished the class. It's because now the time came. I hope you enjoyed.
Thank you, doctor.
You take
Thank
attendance.
you.
Attendance, I already what I was telling you. Attendance, I already opened. If you cannot manage, say write your number and say yes. See, for example, Savai says I am here. Mustafa says I am here.
Okay.
You okay? Okay.
Yes.
See you on Wednesday.
Bye-bye.
Bye bye.
Bye bye.
Goodbye.
Bye bye. Thanks a lot.